thing we're talking about is a pyramid. That would be a polyhedron in which one face, the base, can be any polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex. So as you can see in our example down here, we have one face, our base, that is a rectangle, and all of the other lateral faces are triangles that meet at a common vertex at the top. Now, because our base is a rectangle, we can name this pyramid a rectangular pyramid because a pyramid is named because of its base. Next, we're going to talk about the altitude and height in a pyramid. So that would be the perpendicular segment from the vertex to the plane of the base. So in our example down here, you see we have the altitude or the height that goes from the vertex at the top of your pyramid and is perpendicular to our base down here. Now, the altitude is the segment itself, whereas the height is the length of that segment. Now, the slant height would be the length of the altitude of a lateral face of the pyramid. So this vocab term might be kind of new for you. A slant height is the length of an altitude of a lateral face. So one of the triangular sides, if I draw an altitude on that triangular face, it's going to be considered a slant height. It goes from the vertex along one of the lateral faces, one of the triangles, and is perpendicular to one of the sides of our base down here. Now, a regular pyramid would be a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. So in our example down here, we have a pyramid whose base is a square. Now, if you recall, a square is a regular polygon because it has all sides and all interior angles congruent. Therefore, because our base is a regular polygon, this would be considered a regular pyramid. And in a regular pyramid, all of the lateral faces, all of these triangular sides, are going to be congruent isosceles triangles as well. Now let's talk about the lateral area of a pyramid. So the lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height. Or you can think about it in terms of the formula, lateral area is equal to 1/2 P times L, where P is the perimeter of your base and L actually stands for the slant height. So if we're given a regular pyramid, and that's key, that means your base has to be a regular polygon. So here it would be a square. If I want to find the lateral area of a regular pyramid, where I add up the areas of all of the triangular faces, all I have to do is use this formula. I take 1/2 and multiply it by the perimeter of our square here, and then multiply that by the length of our slant height here, the measure of segment AF.
Example time, example time, example time, rock!
Now example 1 says find the slant height of the regular pyramid below. So we're given that this is a regular pyramid, meaning our base, since it's a quadrilateral, would have to be a square. So in order to find the slant height here, we first need to draw the slant height. And remember, the slant height is just going to be an altitude of one of your lateral faces. Meaning, I'm going to draw a line segment that goes from our vertex and is perpendicular to one of the sides of our base. Now here's a little trick. Anytime they give you an apothem like this, you always want to draw your line segment so that it connects your vertex and the endpoint of that given apothem. The reason is because that's going to help you solve for your slant height. And you say, how does that work? Well, look what I've done here. I've created this little right triangle in our pyramid. Now, this right triangle will then allow us to solve for the slant height because we can use the Pythagorean theorem. A squared plus B squared is equal to C squared. But you think, wait, I only have the length of our altitude, the height of this pyramid. That's one side of our right triangle. We need this other side in order to help us solve for the slant height. So how do I figure out this side? Well, because this is a regular pyramid, that means this base is a square. And because of that, this altitude is going to drop down right smack dab in the center of that square. Meaning, if I then draw an apothem to the side of our triangle over here, the length of this apothem is actually going to be half of one of the side lengths. So if this whole side length is 8 feet, the length of this apothem then would be 4 feet. So now I have two sides of a right triangle and I can solve for the third. So what do I plug in where? Well, remember, it only matters which side you plug in for your C. That has to be the side opposite your 90-degree angle. So that in this case would be our slant height. So that is just going to stay C. We'll solve for C. That means 10 feet and 4 feet can go in for A or B. It doesn't matter which goes in for which. We then square each of those, add them together, and we get C squared is equal to 116 feet squared. Now, how do we solve for C? Well, we need to get rid of the square. So we're going to square root both sides. And anytime you square root a variable squared, on the other side you need to put plus or minus. Now what happens is the square root and the square cancel each other out. We just get C is equal to, and we have rad 116 over here. Now, this doesn't give us any rounding instructions. So what we're going to do is we're going to leave it in simplest radical form. So I need to simplify this radical, which means I need to break it up into two radicals that multiply together to make rad 116. And one of those numbers inside my radicals has to be a perfect square. So what perfect square goes into 116? How about 4? So I'm going to break rad 116 up into rad 4 times rad 29. Now we chose 4 because that's the perfect square. The square root of 4 is going to be 2. Rad 29 is going to stay rad 29. 29 is a prime number. And because we're dealing with side lengths or measurements in a pyramid, we can't have a negative slant height. So we're just going to take the positive version here, the principal root, and we're going to say C is equal to 2 rad 29 feet. Now example 2 says find the lateral area of the regular pyramid below. So we again have a regular pyramid, meaning our base is going to be a regular polygon. And since it's a quadrilateral, that means it's going to be a square. This time they give us the slant height, so that's nice. Well, in order to find the lateral area of a regular pyramid, we need to remember what is the lateral area of a regular pyramid formula. Well, that would be lateral area is equal to 1/2 the perimeter of the base times the slant height. So do we have those things over here? Well, yeah, since this is a regular pyramid, that means our base is a square. So each side has to be 14 centimeters. So the perimeter of our base is just going to be 14 centimeters times 4, or 14 plus 14 plus 14 plus 14 centimeters. Our slant height is 17 centimeters, so that's going to go in here. And now all I have to do is simplify this. So if I simplify inside my parentheses here, multiply this all together, I end up getting that the lateral area of this regular pyramid is 476 centimeters squared, or square centimeters. Now let's talk about the surface area of a pyramid. So the surface area of a regular pyramid is the sum of the lateral area and the area of the base. Or if you want to think about that in terms of our formula, surface area is equal to lateral area plus capital B, which represents the area of the base. So if you recall, surface area is also known as total area because it adds together the areas of all of the sides or faces in your pyramid. It adds together all of the lateral faces, the triangular faces, and then adds the area of the base as well to give you the total area or surface area. In this particular pyramid, we have a regular pyramid, meaning our base has to be a square. So if I want to find the surface area, I take the lateral area, which again was 1/2 the perimeter of your base times the slant height, and then add in the area of your base. And since your base is a square, you just go base times height, or the length of one side squared. Now example 3 says find the surface area of the regular pyramid below. So we again have a regular pyramid, and because our base is a quadrilateral, that means our base is going to be a square because that's a regular quadrilateral. Now, in order to find the surface area of a regular pyramid, we need to remember the surface area of a regular pyramid formula. That would be surface area is equal to the lateral area plus the area of your base. So what is the lateral area again of a pyramid? Well, the lateral area is 1/2 the perimeter of your base times your slant height, and the base here is a square. So if I want to find the area of our square, I just take the length of one side and square it. That's where s squared comes from. So now I just need to plug in what I know. I know that since this is a square, all of these sides are going to be the same. So the perimeter of my base is just going to be 5.3 feet plus 5.3 feet plus 5.3 feet plus 5.3 feet. I'm going to then plug in for my L, my slant height, 4 feet because they give us that. And the area of my base is going to be the length of one side squared because this is a square. So I take 5.3 feet, plug that in for S here, and now all I have to do is just simplify this. I multiply these together, square this, and then add those two quantities together, and I get that the surface area or total area of this regular pyramid is going to be 70.49 feet squared, or square feet.
Spin the dreidel, see where it lands. Then you try.
Okay, we again want to find the surface area of a regular pyramid, and this time our regular pyramid has a base that is a hexagon, so it would be a regular hexagon. So in order to find the surface area of a regular pyramid, we need to remember the surface area of a regular pyramid formula. That would be surface area is equal to the lateral area plus the area of the base. Well, in a regular pyramid, the lateral area is equal to 1/2 the perimeter of your base, which we can find, times the slant height, which we're not given. So we need to find the slant height first. So how do we find the slant height here? Well, the first thing we should do is draw our slant height. Well, remember, the slant height is going to be an altitude of one of the lateral faces or triangles of your pyramid. So how do I draw an altitude here? Well, remember, we said anytime they give you an apothem like this, all you have to do is just draw a line segment connecting the vertex and the endpoint of your given apothem right here. Now that will be considered your slant height. Now the reason we do this is because we now have created this right triangle in here, and we can use this right triangle in order to find our slant height because because we have two side lengths of our right triangle, and we can find the third by using the Pythagorean theorem. Now remember, in the Pythagorean theorem, it only matters what you plug in for C. Your C value has to be the side length opposite your 90-degree angle, which in this case would be our blue apothem right here. That means 5 feet and 12 feet can go in for A or B. It doesn't matter which goes in for which, and we can solve for C, our slant height. So we go ahead and square each of these, add them together, and now we square root both sides. And when we square root both sides, anytime you square root a variable squared, on the other side you have to put plus or minus. Now the square root and the square cancel each other out over here, and on this side the square root of 169 is going to be 13. But the only issue is we're dealing with measurements in a pyramid, and you can't have a negative slant height. So we're just going to take the positive version, the principal root, and we're going to say C is equal to positive 13 feet. So now that we know our slant height is 13 feet, we can go about solving for the surface area of this regular pyramid. So remember, the surface area of a regular pyramid formula is surface area is equal to the lateral area plus the area of a base. And we said the lateral area is equal to 1/2 the perimeter of your base times your slant height, L. We also know that our base is a regular hexagon, meaning in order to find the area of a regular polygon, we have to use the formula area is equal to 1/2 the apothem times the perimeter. Now the good news here is because we have found our slant height, L, we can now plug in something for each of these variables. The perimeter of our base, we know is just going to be 6 feet times 6 sides, so 36 feet. The slant height we now know is 13 feet. That's going to go in for L. The apothem we see is 5 feet, so that goes in for A. And P, again, is the perimeter of your base, which is 36 feet. We now multiply these together, then add those two quantities together, and we get that the surface area of this regular pyramid is 324 feet squared, or square feet. Now example 4 says find the surface area of a regular pyramid below. Leave your answer in simplest radical form. So we again have a regular hexagonal pyramid. We have a pyramid whose base is a regular hexagon. This time though, we are given the slant height and the length of our altitude, the height, but we're not given any measurements in our base. We're not given the apothem and we're not given one of the side lengths. Well, we clearly need both of those things in order to find the surface area here. So let's go about finding the apothem and one of the side lengths. So we'll start with our apothem. How do we find the apothem? Well, the first thing we should do is draw our apothem in our figure. We're going to draw a line segment connecting the endpoint of our slant height and the endpoint of our altitude. We then see that we have created this right triangle here, and we can use the Pythagorean theorem in order to solve for our missing side length, our apothem. Well, remember, in the Pythagorean theorem, it only matters which value you plug in for C. C has to be your hypotenuse, so the side length opposite your 90-degree angle, or the slant height in this case. So I'm going to take 10 feet, plug that in for our C. That means our apothem and this 8 feet can go in for A or B. It doesn't matter which goes in for which. I'm going to let A be our apothem and let B be this 8 feet. So I plug those in there. I didn't square the 8 feet and the 10 feet. I can now solve for A by subtracting 64 feet squared on both sides, getting rid of this square by square rooting both sides. And remember, anytime you square root a variable squared, on the other side you need to put plus or minus. Now the square root and the square cancel each other out. Over here, the square root of 36 we know is going to be 6. And since we are dealing with measurements in a pyramid, we're only going to take the positive version, the principal root. So A, our apothem in this case, is going to be equal to positive 6 feet. Well, since we know our apothem, the only other thing we need to find is one of these side lengths of our base. Because if we find one of these side lengths of our base, we can find the perimeter of our base, and then we can fill out the surface area of a regular pyramid formula. So how do we find one of these side lengths of our base? Well, we've done this before. When you're given a regular polygon and you're given the apothem in that polygon, you can find the side length, or at least half of the side length of your base, by using special right triangles, or trig. So what I'm going to do is I'm going to redraw our base over here, which is a regular hexagon, and I'm going to create a central angle. Now remember, a central angle is an angle formed by the center of your regular hexagon and the endpoints of one of the sides. So I'm going to draw the center of this regular hexagon and draw line segments connecting the center to the endpoints of one of the sides. Now I have created a central angle. Next, I need to find the measure of that central angle. Well, remember, in order to find the measure of a central angle of a regular polygon, you just take 360 degrees and divide it by the number of sides. So here we have 6 sides, so 360 divided by 6 is going to give you 60 degrees. That's the measure of this central angle. Next, I'm going to drop our apothem that goes from the center of this polygon and is perpendicular to this side right here. We know that's 6 feet, so we can label that as such. Now, this apothem is special because it does two things. One is that it bisects our given side length over here, and the second thing is that it bisects our given central angle. So instead of this whole angle being 60 degrees, each of these little angles is going to be 30 degrees. Now what we've done here is we've actually created two little right triangles. And in these little right triangles, we have one acute angle measure that's 30 degrees, meaning the other acute angle measure, if we take 180, subtract 90, subtract 30, we're left with 60 degrees. So we have a 30, 60, 90 degree triangle here. And we know in a 30, 60, 90 degree triangle, everything is based on the short leg, the side opposite the 30 degree angle, which we'll call x in this case. If I take x and multiply that by 2, that will give me the length of our hypotenuse. If I take x, the short leg, and multiply that by rad 3, that'll give me the length of our longer leg, the side opposite the 60 degree angle. Well, if I'm given the length of our longer leg, then all I have to do to find the length of the shorter leg is, instead of multiplying it by rad 3, I'm going to divide this by rad 3, and that'll give me the length of our shorter leg. So if I take 6 feet, divide that by rad 3, I then get x, the length of our shorter leg. So how do I divide 6 and rad 3? Well, we need to rationalize this. So I'm going to multiply the numerator and denominator by rad 3. The reason I do that is because in our denominator, rad 3 times rad 3 gives you rad 9, which is 3. And then in our numerator, we just leave it 6 times rad 3. Now, this 3 can simplify with this 6. It cannot simplify with this rad 3 because this has a radical. This does not. So when I divide the 3 into the 6, and we get 2 rad 3. That's going to be the length of our shorter leg in this 30, 60, 90 degree triangle. Now remember, this apothem not only bisected our central angle, but it bisected this side, meaning if this measurement right here is 2 rad 3 feet, then this measurement right here must also be 2 rad 3 feet, meaning an entire side length of our base must be 4 rad 3 feet. So we know that one of the side lengths of our base must be 4 rad 3 feet. We now have everything we need in order to find the surface area of this regular pyramid. So remember, the surface area of a regular pyramid formula is surface area is equal to the lateral area plus the area of the base. Now remember, the lateral area of a regular pyramid is 1/2 the perimeter of your base times your slant height. The area of our base here, because it's a regular polygon, is going to be 1/2 apothem times perimeter. So now let's fill in each of these variables. P is the perimeter of your base, which is going to be 4 rad 3 feet times 6 sides, so that would be 24 rad 3 feet. We know that our slant height L is going to be 10 feet. We know that our apothem is 6 feet, and we know the perimeter of our base, we just said, was 24 rad 3 feet. So now we need to simplify this, and because it wants our answer in simplest radical form, the 1/2, we multiply that to 24 rad 3 feet. The 1/2 just multiplies to the 24, giving you 12 rad 3 feet. We then take 12 rad 3 feet and multiply it to 10 feet, multiply the 12 and the 10, you get 120 rad 3 feet squared. Over here, we multiply the 1/2 times the 6, which gives you 3 feet, and then 3 feet times 24 rad 3 feet, the 3 and the 24 multiply to give you 72 rad 3 feet squared. Now we just need to add these two quantities together. And remember, when you're adding like radicals, meaning they have the same thing under the radical, all you have to do is just add the coefficients together and keep the radical the same. So treat it like a variable. If you have 9x plus 3x, you get 12x. If you have 120 rad 3 plus 72 rad 3, you get 192 rad 3 feet squared, or square feet. That would be the surface area of this regular pyramid. Now let's talk about a cone. So a cone would be a three-dimensional figure that has a circular base, meaning its base is a circle. It has a vertex not in the plane of the circle, meaning its vertex is either above, below, to the left, or to the right of your given base. And it has a curved lateral surface, meaning it would not be considered a polyhedron. It does not have flat lateral faces. Instead, it has one curved lateral surface. Now looking at this cone in particular, we call it a right cone because it has its vertex directly over the center of the circle. Meaning, if I were to drop an altitude going from the vertex to our base down here, the altitude would be that line segment that connects the vertex and the center of your circle, and it would be perpendicular to your base down here. Now remember, the altitude, we just said, is the perpendicular segment from the vertex to the plane of the base. And when you have a right cone, that altitude goes from the vertex of your cone to the center of the circular base. Now remember, the altitude is the segment itself, whereas the height would be the measure of that segment. Now the slant height is going to be the distance from the vertex to a point on the edge of the base. So if we draw any line segment going from the vertex to some point on the edge of our circular base, that line segment would be considered a slant height. Now let's talk about the lateral area of a cone. So the lateral area of a right cone is half the product of the circumference of the base and the slant height, or lateral area is equal to 1/2 the perimeter of your base times your slant height. So the lateral area of a cone formula is identical to the lateral area of a pyramid formula because a cone is technically just a pyramid with a base that is a circle. So if we were to make this formula so it was more specifically for our cone, remember the perimeter of your base, if your base is a circle, is called the circumference. And the formula for the circumference is 2 pi r. So we can plug in 2 pi r for the perimeter of our base, and the slant height, we still keep L. Now this 1/2 and this 2, we can actually cancel out and just write pi RL. This is also how you typically see the lateral area of a cone formula. But I always like keeping it like this because it's one fewer formula to memorize. We know that lateral area of a pyramid and a cone are exactly the same. The only difference is a cone is just a pyramid with a base that's a circle. Now example 5 says find the slant height of the cone below. Round your answer to the nearest thousandth. So we again have a right cone because our altitude goes from the vertex to the center of our circle down here. We are given the length of our altitude or the height of this cone, and we're given the length of the radius. So how do I find the slant height here? Well, as you can see, we have this little right triangle here. So in order to find the missing side length of a right triangle, we can use the Pythagorean theorem. A squared plus b squared is equal to c squared. And in this formula, it only matters what we plug in for c. C has to be the hypotenuse, the length of the side opposite our 90-degree angle, or our slant height in this case. So that's what we're trying to find. So we're going to leave that as c. That means 24 feet and 7 feet can go in for a or b. It doesn't matter which goes in for which. I then square each of those, add them together, and I get c squared is equal to 625 feet squared. Now, in order to solve for c, I'm going to square root both sides. And anytime you square root a variable that's squared, on the other side you need to put a plus or minus. Over here, the square root and the square cancel each other out. And on this side, the square root of 625 is going to be 25. And because we're dealing with measurements of a cone, we can't have a negative slant height. So we're going to keep it positive. We're going to keep the principal root. And we're going to say C, our slant height, is going to be equal to 25 feet. Now example 6 is find the lateral area of the cone below. Round your answer to the nearest thousandth. So first thing we need to do is remember the lateral area of a cone formula. Well, it's the exact same as the lateral area of a pyramid formula. That would be lateral area is equal to 1/2 the perimeter of your base times your slant height. Only this time our base is a circle, and the perimeter of our base is the circumference of this circle, or 2 pi r. So I'm going to plug in 2 pi r for the perimeter of our base here. Now we're given the radius, that's 6 inches, so that can go in for our r. So the only other thing we need is our slant height, L. Oh, they give us that also, 8 inches. We plug that in for L. Now all we have to do is just simplify this, and we end up getting that the exact lateral area in terms of pi of this cone over here is going to be 48 pi inches squared, or square inches. But because this isn't asking for the exact lateral area, it's asking for you to round your answer to the nearest thousandth. So in your calculator, you're going to multiply 48 and pi, and you're going to round to 3 decimal places, and you get that the approximate lateral area of this cone over here is 150.796 inches squared, or square inches. Now let's talk about the surface area of a cone. So the surface area of a right cone is the sum of the lateral area and the area of the base, or surface area is equal to the lateral area plus the area of the base, capital B. Now remember, this is the exact same surface area formula as the surface area for a pyramid. The only difference this time is we have a circular base. So we could actually rewrite this a little bit if we wanted to. The lateral area, again, is 1/2 the perimeter of your base times your slant height. And since this is a cone, the base is a circle, meaning the perimeter of your base is the circumference, 2 pi r. So it would be 1/2 2 pi r times the slant height, L. Then we add in the area of your base, and since your base is a circle, that would be pi r squared. So if we were to simplify this over here, we end up getting pi rl plus pi r squared. Now this is typically what you see as the surface area of a cone formula. But I just like memorizing this because it gives you fewer formulas to memorize. It's the exact same as the surface area for a pyramid. Now example 7 says find the surface area of the cone below. Round answer to the nearest thousandth. So in order to find the surface area of a cone, you need to remember the surface area of a cone formula. Well, it's the exact same as the surface area of a pyramid formula. Surface area is equal to the lateral area plus the area of the base. And remember, the lateral area of a cone is going to be 1/2 the perimeter of your base times your slant height. And since we're dealing with a cone, that means the base is a circle. So the perimeter of your base is going to be the circumference of this circle, or 2 pi r. We also know that because the base is a circle, that the area of that base is going to be pi r squared. So now what we can do is plug in what we know. We know that the radius of this circle is 7 inches, so that can go in here and here. We know the slant height of this cone is 10 inches, that can go in here. Now all we have to do is simplify. So we multiply these together, multiply these over here together, simplify, and we end up getting, when we add these two quantities together, that the exact surface area of this right cone is going to be 119 pi centimeters squared, or square centimeters. But because this question wants you to round your answer to the nearest thousandth, you just need to multiply 119 and pi in your calculator, and you get that the approximate surface area of this right cone over here is 373.850 centimeters squared, or square centimeters.
Make sure you try better than Santa's tried at losing weight.
Okay, doing the same thing. We want to find the surface area of this right cone below. Now, in order to find the surface area of a cone, we need to remember the surface area of a cone formula. Surface area is equal to the lateral area plus the area of your base. Now, if you recall, the lateral area of your cone is going to be 1/2 the perimeter of your base, or circumference of this circle, times your slant height. So there's one clear issue in evaluating the surface area of this cone. We aren't given the slant height. So that's the first thing we need to find. Let's find the slant height. So how do I find the slant height here? Well, as you can see, within this cone, we have this right triangle here, where we're given this side length, and we're kind of given the side length. We're given the whole diameter of the circle. Well, is there any way we can figure out what this segment right here is equal to? Well, yes, since this is a right cone, our altitude goes from the vertex to the center of our circle down here, meaning that this segment would be considered a radius, which would be half of your diameter. So I know that this segment right here is 3 meters. I know that this segment is 8 meters, meaning I can use the Pythagorean theorem in order to find my slant height. So in my Pythagorean theorem, it only matters what I plug in for C. C has to be the side length opposite my 90-degree angle. So that would be my slant height. That means this 3 meters and this 8 meters can go in for A or B. Doesn't matter which goes in for which. I then square each of those, add them together, and I solve for C by taking the square root of both sides. And when you square root a variable squared, on the other side you need to put plus or minus. Now over here, the square root and the square cancel each other out. And on this side, 73 is actually a prime number, so there's no way I could break this up any further. So it's just going to stay plus or minus rad 73. And because we're dealing with measurements in a cone, we're just going to keep the positive version, or the principal root. And we're going to let C, our slant height over here, equal rad 73 meters. So we can label that over here. Now that we have found our slant height, we can go about filling out our surface area formula. And again, the surface area of a cone formula is surface area is equal to the lateral area plus the area of the base. And remember, lateral area of a cone is going to be 1/2 the perimeter of your base times your slant height. And since our base is a circle, the perimeter of your base is the circumference, which is 2 pi r. And again, because your base is a circle, the area of your base is going to be pi r squared. We can now plug in what we know. Since we know that our diameter is 6 meters, we know our radius must be 3 meters. So we can plug in 3 meters here and here for our radius. Our slant height we just found to be rad 73 meters, so we can plug that in there. Then all we have to do is just simplify over here, and then add those two quantities together, and we end up getting that the surface area of this right cone over here is approximately equal to 108.800 meters squared, or square meters, when we round to the nearest thousandth, which is 3 decimal places. Now I want you to take out your formula sheet that we started in the previous lesson, and you need to fill out the 4 new formulas we have today. We have the lateral area for a pyramid and the surface area for a pyramid. We also have the lateral area for a cone and the surface area for a cone. And the good news is that the lateral area for a pyramid and a cone, that's the same formula. The surface area for a pyramid and a cone, that's the same formula. So we're well on our way to filling out this formula sheet.